So today we're dealing with number 6s, right? A map is drawn to a scale of 1 to 20,000. Now the thing about these scales when they write them is if I talk about 1 centimeter, I talk about 20,000 centimeters also, right? On the map, 1 centimeter represents n kilometers. Determine the value of n. At 1 kilometer is equal to 100,000 centimeters, right? So it's like you're trying to move from centimeters back to kilometers, right? What do? Do we multiply by 100,000 or do we divide by 100,000? Divide. Once you're going from right back to left, you have to divide. So what I can say here is therefore 20,000 centimeters, because you want to express it in kilometers, right? Would be equal to 20,000 divided by 100,000. And what you get in there? 0.2. 0.2 kilometers. So therefore, or this implies that 1 centimeter on the graph would be 0.2 kilometers in real life. Determine the distance on the map in centimeters, which corresponds to an actual distance of 4.8 kilometers, right? So, and we know that 1 is like 1 centimeter is equal to 0.2 kilometers, right? So we want to know what 4.8 kilometers would be. We want to show 4.8 kilometers on the map, but we know 1 centimeter on the map is equal to, is like basically equal to, right, 0.2 kilometers, right? So if I want to find out how much this is on the map, I just need to divide it, right? It'll be 4.8 divided by 0.2 to know how much centimeters it will be on the map, right? So 4.8 kilometers on my map would be 4.8 divided by 0.2. So I want to find out how much 0.2s I could get from 4.8. That will tell me how much centimeters it is on the map. And this will be equal to how much centimeters? 24 centimeters on the map. Right? Everybody good there? Part 3. Determine the actual area in square kilometers, right, of a lake which has an area of 12 centimeters squared on the map, right? So basically on your map, you have 12 centimeters squared. What this means, right? So we on to part 3. What this means, right, is that if you have 1 square box on the map, that is going to be like 1 centimeter by 1 centimeter. The area of this box will be what? 1 by 1, which is 1 centimeter squared, right? So if I was to use kilometers instead of centimeters, right, that 1 centimeter, right, would be 0.2 kilometers by 0.2 kilometers. That will tell me how much kilometers squared one box is, right? So this will be 0.2 multiplied by 0.2, which will be how much? 0 point something, 0.04 kilometers squared. So one box, 1 square centimeter on the graph is 0.04 kilometers squared in real life. And how much centimeters squared we looking at? How much? So if we're looking at 12 centimeters squared, I simply need to multiply 12 by 0.04 in order to find out how many square kilometers it is in real life. Are we clear? So this will be 0.04 multiplied by 12. How many kilometers squared is this in real life? 0.48. 0.48 kilometers squared. The diagram below shows a running belt. E, F, G, H, I, J, E. That's right around, right? That revolves around a running board on a treadmill, right? So this is like the side view of the treadmill as I was saying, right? So in the diagram, E, J, I. So E to J, I and H to G to F are semicircles with a diameter of 0.7 meters. And EFHI is a rectangle, right? So they basically asking you for the perimeter of this compound shape here. This compound shape consists of a rectangle and 2 semicircles, right? If I find the circumference of the circle, I would be able to determine what the perimeter, well, the length of the two arcs are there, the semicircle arcs, right? And then if above there's 2.1, what underneath here would be? Boom, 2.1 meters, right? So let's proceed to find the circumference of what would be a circle when the two circumferences come together, right? But the two arcs come together. So there you go. This is B part 1, right? So we on to B part 1, right? So we're gonna find the circumference of the circle, right? What the circumference of the circle would be? What's the formula? 2 pi r, or diameter by pi, right? I will use diameter by pi because we had the diameter there. Okay, 0.7 was my diameter. Multiply by, did it tell us to use pi as anything? 22 over 7, normal 22 over 7. 22 over 7. When I multiply this, what will be the circumference of my circle? 2.2, and this is what? Centimeters? Meters. 2.2 would be here and here. So it's like here's 1.1 meters and here's 1.1. You all agree? Because the whole thing is 2.2. Everybody good there? I just divided by 2. 2.2 divided by 2 be 1.1, right? So I want to find the length of my belt. What will be the length of my belt, my children? I'll put it 2.2 plus, was it 2.1 plus 2.1? What is the length of the belt?
6.4 meters.
Glenda uses the equipment to exercise 4 times a week and runs at 9 kilometers per hour for 20 minutes each time. Calculate the number of complete revolutions the running belt makes in 1 week during Glenda's exercise routine, right? Some things I know. Could we agree that the perimeter of this running belt, right, would be 1 revolution, right? So 1 revolution is actually 6.4 meters. Everybody good there? So if I can find out how much meters the person ran for the entire week, which is actually the distance, right, for the entire week, I could calculate how much revolutions they made. Anybody was able to articulate that? You find the distance. They gave us, did you all realize they gave us the speed? They gave us the speed because it's kilometers. Wait, this is kilometers. It's not meters. Everything here is in meters. I want to change that to meters per hour one time. So 9 kilometers per hour would be the equivalent of how many meters in a kilometer? How much meters in a kilometer? 1 kilometer is 1,000 meters, right? So 9 kilometers per hour can be expressed as 9,000 meters per hour. Everybody get there? 9 kilometers would be equal to 9 multiplied by 1,000, which is 9,000 meters per hour from. All right? How we looking there? We looking good? Right. So, what we're going to try to figure out now, let's go back to the question, right? So it's 9,000 meters per hour for 20 minutes. But this is also minutes represented as a fraction of an hour. 20 minutes will be how much? 20 over 60. Excellent. 20 over 60, which will be what fraction of an hour? 1/3 of an hour. Everybody good there? So this is my time, right? And this is my speed. Okay? Distance. I want to find the distance that this person is running for the entire week. So my distance, what is the formula for distance?
Speed multiplied by 10.
Right. But let me show you how we building that. What's the original formula, Kyle? The original formula is
Speed is equal to distance over time.
proper. Speed is equal to distance over time. I told you all changing the subject of the formula is life in maths, right? Your lifeline in maths is changing the subject of the formula. So if I want to find distance here, what do I do? I do move this time here, and what do I do with it? And when I do that, what would I get? I would get distance is equal to speed multiplied by time, right? Speed multiplied by time, right? Do I have my speed? Yes, I do. What is my speed? 9,000 multiplied by what is my time? 1/3, because time is reflected in hours, right? So what would be my distance here, my children?
So 3,000.
3,000 what? Meters. Everybody agrees? How much time this person doing this 3,000 meters in a week, boy? 4 times, boy. We cooking with gas, right? 4 times a week. What is a woman, big girl, making 4 times 3,000 meters in running per week? So how much I'll be, boy? So I'm gonna put distance for the week, right? So distance in 1 week would be equal to 4 times 3,000. How much you getting there? 12,000 meters, right? So compose yourself. Compose yourself, right? 12,000 meters in 1 week, right? How much is one revolution or one belt? Because the question asks to calculate the number of complete revolutions. What is the distance of one complete revolution, Andrew? 6.4. We cooking. So if you make 12,000 meters a week, how much complete revolutions would you make? Complete revolutions made. 12,000 what? Divided by 6.4. So I basically want to know how much 6.4s I could get from 12,000. Right? And how much you get? 18 what?
75.
I also got that, so yeah.
Papa. June 2025, right? Question 6. PMQROS is the cross section of a play area in a park. PQRS is a rectangle and PMQ is a semicircle, right? O is the midpoint. So O in the middle here. So that's points to note. If O in the middle, that means here and here are equal also, right? These two lines are equal. OP, O to P is equal to O to Q, which is 15 meters, right? And angle P to O to Q is 40. This is the only thing they gave us, right? So if I'm asking for angle OPQ, which is here, this is an isosceles triangle. It is plain as day. Base angles in an isosceles triangle are equal. These two lines are equal, meaning that these two angles are equal here. Cool? So let's work. That's all the work we put in here now. We just put in OPQ is equal to the three angles of a triangle add up to 180 degrees, right? So this will be 180 minus the 40. And if I divide this by 2, I will get my
70.
how much again? 70.
70.
70 degrees, right? Everybody good there? So with that information now, I want you all to calculate the length of OR. I've given you all. So I'm going to say it again, right? They want us to find OR for part 2. But a piece of information was given above here that makes us determine that this is a right angle, right? So in order to deduce that here is a right angle, I needed to look at this information here. They said that PQRS is a rectangle. All the corner angles in a rectangle are 90 degrees, right? So if I want this length here, which is OR, this is clearly right angle, right? Boom, bang, right? And then come in here. This is what you're all focusing on, right? This triangle is a right angle triangle. We have the hypotenuse. We have one side. In order to find the next side, we are going to apply Pythagoras' theorem. So Pythagoras' theorem, if you want to find a side, we call that side B. So B squared is equal to A squared minus C squared. A squared being the hypotenuse squared, right? Common B being the side we want to find, which is OR. So OR squared would be equal to common A, which is 15 squared minus common C, which is 14.1 squared. OR would be equal to the square root of what? 26.19. Everybody good there? Somebody second that? You get that, bro? Right. So OR would be equal to what?
5.1.
5.1 meters. Everybody agrees? Meters, right? Now, by finding this 5.1 here, my brothers and sisters, I know that the next side is 5.1, eh? And here's 5.1 too. Because this is the midpoint. They said O was the midpoint. Everybody good there? We cooking with gas? Saying it again. The area of the semicircle is the first thing we're going to find. That is up here. Right? Watch it. That is the area of this bad boy up here. Right? The area of this semicircle is basically theta over 360 because it's like a semicircle is like a sector. 40.9. And this will be meters. Is it meters? Was this meters? Meters squared. That's the area of the semicircle. Now we need to proceed to find the area of the triangle. Right? Because the next shape we have underneath here would be a triangle. Everybody agrees? Is this a triangle? Yes, it is. What is the base of the triangle? The base of the triangle will be this length here. Boom. This is my base. How do I find that base? 5.1 plus 5.1, 10.2, right? This is an isosceles triangle. Everybody agrees? So if it's an isosceles triangle here, the perpendicular height in the middle here would be the height of the triangle, right? And this perpendicular height would actually be 14.1 meters. Everybody agrees? So we have the base. What the base is? 10.2? 10.2. 10.2 meters. Base multiplied by height divided by, let's work. Right? We didn't come here to lose. Right? So this will be equal to base multiplied by height all over dose. Base was what? 10.2 multiplied by height, which was all over 2. What is the area of my triangle? 70. You sure? Nah, I had to multiply the top then divided by 2. Yeah.
71.91.
71.9, yeah, correct. 71.9, right? And this is meters squared. So, going back to what the question asked, they asked us the area of the shaded region. That'll be 40.9 plus 71.1. What will be the area of my shaded region? 0.8. How we cooking? So we need to find the perimeter of the cross section PMQROS, which is the entire shape, right? So watch me. What we talking about here for the perimeter is all around. So starting with this arc here, which is a semicircular arc, boom, right? And then you have this length here, bang. Then you have this length underneath here, bang, right? And then you have here, bang. Everybody good there? So what we have here is 14.1. Everybody agrees? Well, underneath here will be 10.2. We need to find the length of the arc. Please and thanks. Right? Okay? Let's build that one time now. Are ready to roll. What is this? This was B part 1 or it was C? Let's confirm that. C. Yeah, it's C. All right, so we're going to C. This is the perimeter. Perimeter would be equal to the length of the arc. Let me find the length of the arc underneath here, right? Length of the arc, which is the half of the circumference, would be theta over 360 multiplied by 2 pi r. Right? Theta in this case would have been 180 over 360 multiplied by 22 over 7 multiplied by 5.1. And what again for the length of your arc? 16.03. And this is meters, right? That's the length of the arc. So my perimeter, I can start with the 16.03 plus, I believe it's 14.1 plus 10.2, which is the underneath, plus 14.1 on the other side, right? So what would be my perimeter? Meters. It's perimeter, so it's just meters. Everybody good there? So we are on to January 2025, question 6, right? I told you how to visualize it, right? A piece of wire is 61 centimeters. See a piece of wire. You bend the wire up, you make a vertex down here, bend it up, you make 2 radii, right? And then you take the other 2 parts down and you fold it on top to complete your arc, right? So the perimeter of this entire sector here would be 61 centimeters. They said the sector of a semicircle OPQ has center O and radius 18 centimeters. So that means here is 18 centimeters also. But I know that the perimeter of this shape is 61 centimeters. So I could know what the length of the arc is by simply doing 61 minus 18 plus 18. Everybody agrees? Right? And what you get in the length of the arc to be? 25 centimeters. That is the length of my arc, right? Length of arc is equal to 25 centimeters. So I go and use the length of an arc formula now, equate it to 25, and work back to get x. Because then x is theta in this case. X is the unknown angle, right? So length of an arc formula, I'll go and put it right here. Length of an arc formula would simply be theta over 360 multiplied by 2 pi r. Everybody agrees? Let's work, right? So therefore, theta is x. So it'll be x over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 18. And this will be equal to what is the length of the arc? 21 centimeters. No, not 21, 25. And I even put in centimeters there. I just need to put 25, right? Everybody good there? We cooking? Here what I want all you to do first. Calculate this bad boy here. Hey, all you're changing the subject of our formula is everything in maths, you know, boy. Everything, you know. Work out that in my square brackets there. Take what you get, carry it on the side, divide it one time. Right? So x over 360 would be equal to 25 divided by what? 113.14, right? And then you're busting 360 here and you're multiplying it by what you get when you divide this, right? So this will be x is equal to 25. I can do it like this, 25.3.14 multiplied by 360, because when the 360 goes to the right, it needs to be multiplied. So x will be equal to what? So just 5, right? So this will be approximately 80 degrees. Area of sector, which is the area enclosed by the wire, would be theta over 360 multiplied by pi r squared. The whole world should be getting this correct. 80 is theta, 80 is the angle over 360 multiplied by 22 over 7 multiplied by 18 squared. And when you work out this way again?
226.29 square centimeters.
Squared. Boom, there you go. A cylindrical block of cheese has a radius of 12 centimeters and a height of 8 centimeters, right? So 12 centimeters would be your radius, and your height here, which is the distance between the two cross sections, would be 8 centimeters, right? The cheese is divided into equal slices. The uniform cross section of a slice of cheese is a sector whose angle is 18 degrees. As shown in the diagram below, calculate the length of the arc. What is the formula for length of an arc? If you write these things over and over, right, it would stick in your head. What it is? Proper. Right? All you realize, no matter how much times I teach you, no matter how much I think you'll know, I always write my formulas. All you realize that, Those who with me since Genesis know that. I don't care how much times we write in it, right? So let me go. Theta in this case is what? 18 over 360 multiplied by 2 multiplied by 22 over 7. I think they had that from above, right? Multiplied by radius, which is 12. And when we calculate this, what will be the length of my arc?
3.77 centimeters.
3.77. All right. Determine the area of the curved surface, right? Or the curved face. Now we calculated here to be 3.77 centimeters. And what's this length here? BC. BC is what? 8 centimeters. Simple rectangle, right? So the area of A, B, C, D would be equal to length multiplied by breadth, which is 3.77 multiplied by 8. And what we getting here, my children?
30.16 square centimeters.
Centimeters squared. Proper. Given the area of OAB, OAB being the sector above here, you see this? This is the sector, aka cross section for this question, right? So they gave you the area of the sector, it's 22.6 centimeters squared. Calculate the volume of the entire block of cheese. The volume of any prism, because that block of cheese above is a prism, it will be the area of the cross section which they gave us multiplied by the distance between the two cross sections. The distance between the two cross sections will be like the distance from here to here, or the distance from here to here. The distance from here to here is the distance between the two cross sections. And that distance is 8 centimeters. Everybody good there? So this will be equal to 22.6 multiplied by 8, which will give me what here, my children? Centimeters what? Cube. So what year I said this was? This is what? June 2024, right? So the diagram below shows a gold bar in the shape of a trapezoidal prism, right? Its volume is 2,806, right? And 86, sorry. The length and height of the prism are indicated in the diagram below, right? You have the length of the prism and you have the height. So you see why this could tie up a student. Look how they use the words length and height here. Which one is really the distance between the two cross sections? The length or the height? The length. Yeah? The distance between the two cross sections is from here, right, to here. You all seen that? So the length is the distance between the two cross sections, which is very important. And that's why I try to not use area of the cross section multiplied by length or height. Because sometimes we'll bounce up something like this and you don't know. Some students, the student who doesn't really understand it properly, and that's dependent on length or height, they lost. They don't know which one to use. Right? So let's go. Calculate the area of the shaded cross section of the trapezoidal prism, right? So I have the volume. Volume is equal to the area of the cross section multiplied by the distance between the cross sections, right? Once you use this formula, you can't go wrong, right? Okay, so we don't know the area, and we don't know the area, but and you know the volume. What's the volume? 2,886, and we know the distance between the two cross sections. What's the distance between the two cross sections? 31.2. If I want to find area, what do we do with this bad boy? And do what? Area would be equal to 2,886 divided by 31.2. What would be my area?
92.5. 92.5.
And this is centimeters squared, because it is an area. So the cuboid-shaped gold bar shown below has the same volume as the trapezoidal prism below. So we're working with 2,886 centimeters cubed for this prism also, right? They gave us the length, they gave us the width, they did not give us the height. What is the formula for volume of a cuboid? It will be length multiplied by width multiplied by height. Okay? And we have the volume. What's the volume? And we have the length. What's the length? And we have the width. What's the width? Do we know the height? So what we do now? Take this bad boy and what you doing with it when you carry there? What you doing with it when you carry there? Yeah, but you have to work it out first. What are you dividing by? Somebody tell me what I'm dividing by. So here was 250.92 and what my answer will be here? 11 point what? 11.5. And this is centimeters. The trapezoidal gold bar, which is some above, right, is melted down and all the gold is used to make 6 identical spheres, right? Calculate for each sphere of gold its radius, right? Now they gave us the formula for volume of a sphere. You all see that here the volume of a sphere is equal to 4/3 pi r to the third power. So first I will find the volume of one sphere. That will be equal to 2,886, which is the volume of the trapezoidal gold bar above, right? This was 2,886 centimeters cubed, right? Divided by 6, what's the volume of one sphere? 481 centimeters cubed, right? So therefore, I'm going to use this formula here now. So therefore, volume, which is equal to 4/3 pi r cubed, right? I'm going to tell you something. Changing the subject of your formula is everything in maths, right? What's my volume here? Why replacing V with? 481. Right? And this will be equal to 4/3. What is pi? Pi was 22/7, I believe. Multiply by 22/7 radius cubed. And r is the only unknown here. So let's change the subject of our formula. What we do with this bad boy when we carry it here? Well, you have to work it out, of course. What you do with it when you carry it there? Divide. Let me divide. Right? So this will be 481 divided by what? What you get when you work out this? Give it as a fraction now.
88/21.
88/21 is equal to r to the third power, right? What you get when you divide this? 114.8 is equal to r to the third power. Now we need to do the opposite of cube on this side, which is cube root. You see a little tree? 114.8 is equal to r. You need to find the cube root of 114.8 to get there. 4.86. And this is centimeters, and
Yeah.
would be my radius. So I want the surface area of one of the spheres, right? Surface area would be equal, they give you the formula here, 4 pi r squared. So this will be equal to 4 multiplied by 22/7 multiplied by 4.86 squared. And what is the surface area of my sphere? 0.93 centimeters squared. Everybody good there? Density multiplied by volume is equal to mass, right? Our density is 19.3. Our volume is 481. What will be our mass? 9,283.3, right? And this will be, since it's mass, it will be this measure here, right? This is your mass measure. So that would be grams, but they want it to the nearest. So how many? 1 kilogram is equal to how much grams? 1 kilogram is equal to 1,000 grams. So you want to go from grams back to kilograms. What do we do? Multiply or divide? Divide. Right? So this would be, your mass would be equal to 9283.3 divided by 1,000. We go into the next kilogram. So what does it give me?
9.2.
9.28, but that will be what? To the nearest kilogram or the nearest whole number. That will be 9.28 kilograms would be approximately 9 kilograms. All right? So we on to January 2024. In this question, we're going to use pi as 22/7. The diagram shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12, right? Diameter here is 12, so that means my radius would be 6, right? The height is 17 centimeters and the radius of the bowl is represented by r. Show that the volume of the cylindrical tin is 1923 centimeters cubed, correct to 4 significant figures, right? So we're going to 4 significant figures, but let me go. Volume of a cylinder would be equal to pi r squared multiplied by height, right? Pi will be 22/7 multiplied by radius, which is 12. Let me put 12 divided by 2, 6 squared, right? Multiplied by a height, which is 17. And when we work out this, what will be the volume of my cylinder? Give me the 2 decimal places and then I'll write approximately how much? So 4 significant figures. The bowl is completely filled with soup, right? When all the soup is poured into an empty cylindrical tin, 90% of the volume of the tin is filled. Calculate the radius of the bowl now, and they give us the formula for volume of a sphere. Half of a sphere, which is a hemisphere, right? So if you want like the volume of a hemisphere, you'd have to divide this by 2. Everybody good there? So we know we could calculate the volume. It's 90% full. So the volume of the bowl, which is our hemisphere, would be equal to 90% or 90/100 multiplied by what was the volume of the cylindrical tin? Right, 1730.7 centimeters cube. Right, that's the volume of the bowl. But this volume now, we're working with this formula up here. We're working with this formula here. So volume of our hemisphere, so volume of the hemisphere, which is the bowl, would be equal to 4/3 pi r to the 3rd power divided by 2. Because this formula up here is the volume of a full sphere, right? So we work it, and we are the volume of the hemisphere. Look, we just work it out here. This will be, I come into the corner here, right? So this will be 1730.7 is equal to 4/3. Pi is what? 22/7 by r to the 3rd power. We don't know rn. Yeah, we're trying to find the radius of the bowl. We don't know r. So we're leaving this as r to the 3rd power all over 2. Changing the subject of our formula once again. What the first thing we had to move here? The 2. Where carrying 2 across here and do? Boom. Let me multiply that one time now. Give me 1730.7 multiplied by 2. 61 is equal to, give me 4/3 multiplied by 22/7. What are we? 88/20. 88/21 r to the 3rd power. What are we moving next? This whole thing moving, 88/21 comes over here. This will be 3461.4 divided by 88/21 is equal to r to the 3rd power. Alright? And when you work out that way again, therefore r would be equal to the cube root of what? So you're trying to find the cube root of 826.02, right? 9.38 centimeters would be my radius. So that's going back through this, right? They told us that the volume of the bowl was poured into the cylinder and it came up to 90% of the volume of the tin, the cylindrical tin, right? So I found 90% or 90/100 multiplied by the volume of the cylindrical tin, which is this, right? That worked out to be 1730.7 centimeters cubed. The volume of a hemisphere would be the volume of a sphere divided by 2, right? Half, that is this here. This is what we call a hemisphere or a hemispherical bowl, right? Okay, this is your hemisphere here. So we're going on. I took what I just got here, which is this volume, equated it to this formula, right? That is what I did here. 1730.7 is equal to the volume of our sphere divided by 2 because that's the volume of our hemisphere. I started to move things. I carry 2 to this side. I multiply here by 2. I got 3,461.4. Then I multiply 4 over 3 by 22 over 7. I got 88 over 21. Carry 88 over 21 to the left. Did the opposite of multiply, which is to divide, right? I divided these things here. I got 826.02. I needed to do the opposite of cube on this side, which would be cube root, right? The cube root of 826.02 would be 9.38. This would be the radius of my hemispherical bowl. Everybody good there? Going together, right? So in the diagram below, points L, M, and N are on the circumference. All these bad boys are on the circumference of my circle, right? Well, my semicircle with center O and radius 18 centimeters squared. So here, man, feel me, right? NT has 18 centimeters. That is a radius. Well, one of the radius, right? NT has 18 centimeters also, another radius. And here is 18 centimeters also, another radius, right? So we have 3 lengths that we could have stated here by just knowing that the radius of your semicircle is 18 centimeters, right? Calculate the total area of the shaded sections in the diagram. They want these bad boys here. We have a semicircle. We can find the area of the semicircle. We have a triangle. Kind of find the area of the triangle. And then what you do with it? Take it away. Come on, man. This is food. Area of semicircle, which is actually a sector. I just love my sector formula, right? So it'll be theta over 360. What is the amount of degrees in this semicircle? How much degrees that is? 180 over 360 multiplied by pi, which is 22 over 7, multiplied by your radius, which is what? 18 squared. What is the area of the semicircle here? Anybody work it out? What we get? 14, right? And this would be centimeters squared. That's the area of the semicircle. That's the full thing, right? That is everything, including the triangle, right? So if I want the area of the shaded region, I must now proceed to find the area of my triangle. Area of triangle would be what? Base and length. Base multiplied by height all over 2. What is the base of this triangle here, my children? 36. Boom. 18 plus 18 will give me my base, right? 36. Multiplied by my height, which is also, what's the height here? 18 all over those. What you getting here for the area of the triangle? 324 centimeters squared. Therefore, the area of the shaded regions would be equal to 509.14 minus 324. And what would we get here? They said in this question, take pi to be 22 over 7 and the volume V of a cone with radius r and height h as volume is equal to 1/3 of pi r squared by height, right? They gave you those 2 facts there, right? So what is the question asking us for? Let me see what's going on here. So they said the diagram below shows a sector OMRN, right? So you have OMRN, O to M to R, which is here, to N, right? That is a sector. They said radius is 12 centimeters. Let me ask a question. What would be the length of OM if this radius on the side here is 12? What would be this length here? 12, right? Lock that in one time. And the sector angle is 168. Sector angle is clear as day here. What does this represent? This is what? What we call this? Theta, right? That is theta. That's my sector angle. It is theta. which was formed by using a thin sheet of metal, right? That's what's going on with this sector, right? So calculate the perimeter of the sector above made from the thin sheet of metal, right? Question. Perimeter means what? What is perimeter online? Face to face. What is perimeter? Distance around. We already have the length of two sides there. We have the two radii, but we are missing the what? What do we call this curve length here? You see this bad boy here? This is called my arc. Arc, okay? What is my formula to find the length of an arc?
Theta over Q6s by 2 pi.
Proper by 2 pi r, right? It don't get any easier than this, right? You have the 12, you have the 12. You just need to find this length, which is my arc. I have it highlighted in orange here, right? So let's just substitute here. It's a substitution game now. Come on, substitution is the game here now. What is theta? What is theta? 168, boom. 168 over 360 multiplied by 2, multiplied by what did the question say to use as pi? 22 over 7, multiplied by what is my radius? What is my radius here? What is r? 12, come on, 12, right? So when we build this out here, what will be the length of the arc? 35.2, and this would be centimeters. Somebody need to second this, sir. Right, proper. So my arc length would be 35.2 centimeters, okay? That would be the distance from M to R to N, right? Now, the question did not ask me to find the length of an arc, right? The question asked me for the perimeter. So therefore, my perimeter will be equal to what? 12 plus 12 plus proper. Hit me hard.
9.2.
59.2. We ain't come here to lose. Right? This is centimeters, right? Right. So watch it. A cone is made from the sector in E, which is what I brought down here. That's this bad boy here. By joining ON to OM. Right? Or OM to ON as shown below. So basically just take these two lengths so, and it just, so they like this. And it just bring them together so. So they like this, and it just bring them together, so they'll be joined, and it will form a cone. So what that creates now is that the length of this arc would become the circumference of this circle. Right? You all seen it there? I'm going to say it again. The length of this arc would become the circumference of this circle at the base here. So once you have the circumference of the circle, you can work back. What is the formula for circumference? First of all, circumference of a circle is equal to what? Circumference of a circle is 2 pi r, or they also give it as diameter multiplied by pi, right? Anyone, okay? We'll use the one with r in it because I want to find r, okay? So the circumference of the circle, which is 2 pi r, would be equal to the length of this arc. Are we clear? So that'll be equal to 35.2. 35.2. Okay? We cooking. Now, if I want to find r, and you know what pi is? What's pi? 22 over 7 by r is equal to 35.2. Right? 2 multiplied by 22 over 7 will give me 44 over 7. That 44 over 7, which is what we get when we multiply this, you could carry it on this side and do what with it? Divide. So look at coming right here. Okay? This will be r. R remains on the left. This will be equal to 35.2 divided by 44 over 7. So this would be equal to 5.6 centimeters, right? That is my radius. So underneath here would be 5.6 centimeters. Next, they asked us to find the height of the cone, right? Which is here. This h in the middle here is what they want us to find. Now, this length OM, from the sector, what is the length of OM? 12 centimeters. Are you all seeing a right angle triangle plain as they here? What can we use to find this, which is a side? What? Pythagoras' theorem, right? Pythagoras' theorem states that theorem, right? If you have a right angle triangle, boom, bang, bang, right angle triangle, okay, this is your hypotenuse. We'll label this A, B, C. If you want A squared is equal to B squared plus C squared. If you want to find B, B squared is equal to A squared minus C squared. And then if you want C, C squared is equal to A squared minus B squared, right? We want to find B, so all I have to do here, B is given by height. So I'll put h squared, right? Therefore, h squared is equal to, what is my hypotenuse here again? What's my hypotenuse? 12. 12 squared minus, what is the other side? 5.6 squared. H squared is equal to what? Or let's just put h one time. So h is equal to the square root of what? Where you get
112.64.
112.64. So h should be equal to 10.61 or just 10.6. Let's go with 10.6, right? Centimeters. So next they want us to calculate the capacity of the cone in liters, right? Just a point to note before we even jump into the question, right? 1 liter is equal to how much centimeters cube? Anybody knows? 1,000 centimeters cube, right? We're working with this, okay? So, one more thing. What is the volume of a cone? It was given above here. CXC was generous enough to put it in the question. Look at this right up here. Look at here, boom. Volume of your cone, right? Okay, volume of a cone with radius r and height h is given by 1/3 of pi r squared by height. Let me write that down here. 1/3 of pi r squared by height. You have r, you have h, you have pi. Somebody tell me what r is now. Let me do this one time. What's r? We just work out r. 5.6, right? What is height? And well, we know pi is 22/7, right? Let's work. Let me add this person quick here. Substitution game now, eh? So let's go. Volume would be equal to 1/3 multiplied by 22/7 multiplied by radius, which is 5.6 squared, multiplied by height, which is 10.6. Volume would be equal to what? 348.25 centimeters what? Cube. But how did my question say they want their answer? In what? What is the measure? Liters. So, universal code, if you're going from centimeters cube, which is the on the right, back to the left, do we multiply or do we divide? Divide. So I'm dividing by 1,000, right? So this will be 348.25 divided by 1,000. How many liters would this volume be? 0.4, let me go 35, sorry. 0.35 liters. So we are on to January 2023, number 6, right? In this question, use pi as 22/7. The diagram below shows a scale drawing of a running track. It consists of a rectangle and two semicircles with diameter Ln and MP. Ln is equal to MP, which is equal to 49 meters, and Lm is equal to NP, right, which is equal to 98 meters. So, question, if here is 98 meters, what would up here be?
98.
And these two semicircles come together to just form a circle. So can I just find circumference of the circle? I could do that because they asked us to show that the total length of the running track is 350 meters. Total length of the running track is the distance around, including these two semicircles, right? So I'm going to just find the circumference of what would be a circle, 2 pi r, or pi by diameter, diameter by pi, same thing, right? I'll just use diameter by pi or pi by diameter because we have the diameter here, right? The diameter is the distance from L to N here. So that will be 22 over 7 multiplied by 49, which will give me what?
154.
154 meters. 77 meters here and 77 meters here. Everybody agrees? That's the length of the two half circumferences, right? So let me work. Therefore, my perimeter, which is my distance around, would be 154 meters plus 89, was it? 89, no, 98 plus 98. What would be the perimeter? It's supposed to be 350. Did you all get 350 when you add up those things?
Yeah.
Proper.
Yes, sir.
A little box to indicate that it was shown. So Nathan walks at a constant rate of 1.4 meters per second. That's his speed, right? Calculate the time it will take for him to walk 7 laps around the track, right? 7 laps. So we have his speed. What is his speed? Speed is equal to 1.4 meters per second. What will be, now we want to find the time, calculate the time. Now what will be his distance? 7 times around the track means his distance will be 7 multiplied by one distance around the track would be 350. And this is distance, so it will be what? In meters, right? So if I want to find time, what I can do to this formula? Could I carry this here and then bring this here? So time, all right, let us put T. Time would be equal to distance divided by speed. So let's plug it in. Time would be equal to, what's my distance? 2450 divided by what's my speed? 1.4. Therefore, your time would be equal to what?
1750.
And this will be in what? Seconds, because it was meters per second, right? So they said Tafari runs 1 lap of the track in 68 seconds, right? Determine the number of laps Tafari can complete in 1 hour running at the same speed, right? So if you take in 68 seconds, I need to find out how much seconds in 1 hour, right? How many seconds would we have in 1 hour? I'll put seconds in 1 hour, right? So let's go, build it up, right? How many seconds we have in a minute? 60, right? How many minutes in 1 hour? 60. So that's it there. 60 multiplied by 60 would be what? 3600 seconds, right? So I found out how many seconds in 1 hour, and he running 1 lap in 68 seconds, right? So therefore, how many laps did he run? So number of laps would be equal to, what we do, multiplying or dividing? Making. So I need to divide. Divided by 68. How much laps Big Man making? How much? 52 laps.
So after the point
would be 52 laps is how much he completes. Right? He did not complete the 53rd lap. Cool? The question asks the number of laps Tafari can complete. So Nathan completes running 1 lap of the track every 72 seconds, right? Tafari took 68 seconds. That was from above here for 1 lap, right? Completing the lap faster. Tafari or Nathan? Tafari. So he took the shorter time, so he finished it quicker, right? So Tafari and Nathan start running at the same time from point L on the track, right? So both of them starting from the same point, okay? Now, each completed a number of tracks, a number of laps of the track. Calculate the least number of laps that each will complete before they are both at point L again. So if they start running at the same time and they're going round and around, and we want to find out how much laps it'll take before they meet back up, the first thing we need to do is we need to find the LCM of these two numbers here, the 2 seconds, right? And then in order to find out who takes what amount of laps, you need to divide 68 into the seconds that we're going to get for the LCM, and then 72 into the seconds that we'll get for the LCM, right? So let's start by LCM. You remember how to work out LCM? Tell me if you remember this. You're putting 68 and you're putting 72. And what number you're starting with? 2 into 68 is 34. 2 into 72 is what? 36, right? And then we could do 17 because this is a prime number. So you run 17 into 17 1. And 17 cannot go into 18, so you bring down 18, and then you can run 18 into 18 as 1. Right? So your LCM would be equal to, you're multiplying all these numbers, right? 2 2s are 4, so it'll be 4 multiplied by 17 multiplied by 18. What are you getting here?
1224.
1224, right? So this will be the seconds. So it's like, this is the amount of seconds each one will take before they end back up at the same point. But we need to know laps. We don't need to know seconds, right? So Tafari completes how much laps? It will be 1224 divided by 6. Tafari was 68, right? 68. And this will be 1224 divided by 72. What we getting here? What we getting here?
18 for Tafari.
18 for Tafari. And how much, Nathan?
17.
17. Boom, bang. Right, so we are on to June 2022, right? So they said the diagram below shows a solid made from a semicircular cylindrical base with a rectangular prism above it, right? The diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So on the side there, this here, right? This shape on the side here, what the shape would be? A what? Who could tell me? Square, because it's 4, 4, right? That's a square, right? We have a semicircle underneath here too. This is a semicircle. So they want you to calculate the total surface area of the solid, right? Now the surface area of a cylinder, right? The surface area of a cylinder with radius r is given by this. So if I find half of this, and I could find the total surface area of this semicircular cylinder underneath here, right? So let me work. So I'm going to put surface area of semicircular cylinder, right? So what should I do? I put in the formula as 2 pi r squared plus 2 pi r by height all over 2. Wherever you get divided by 2, right? But you all seen something here? You all seen 2 could be divided here and here? So this is going to be equal to pi r squared plus pi r by height. So what is pi 22/7? What is radius? If the length from here to here is 4, that means the length from here to here is 4 centimeters. So what would my radius be here? 2. You all see that? 2, right? So I can put when radius is equal to 2 centimeters and height. What is the height of the cylinder? Let me see who's seen it. What is the height? Right? Proper. It is 12. The distance from here to here would be the height of the cylinder, right? That is 12 centimeters. So H is 12. So let's find the surface area of the semicircular cylinder, right? So therefore, surface area would be equal to pi, which is 22 over 7, multiplied by my radius, which is 2, plus 22 over 7, multiplied by my radius, which is 2, and my height, which is 12. This is supposed to be 2 squared because it was r squared. So run it. Somebody run it and give me the answer. Third, fourth, fifth. Right, so there we go. That is the surface area of the semicircular cylinder. But that's not what the question asks. The question asks the total surface area, right? So my total surface area would be equal to 88 is part of it, right? Okay, so there we go. That would be 88 would be the curved surface here, right? You see this curved surface here? Plus the two semicircles. That is where the 88 comes from. Let's see how much more surfaces we have, right? Why did I put that equal sign here? Right, so it'll be 88 plus, give me another surface that is not included in the 88 there. Give me the working for the area of that. So what I did is I multiplied 12 by 4 by 3 because we have three 12 by 4 sides, right? It'll be the one in front, the one behind, and the one on top, right? The one in front, the one behind, and the one on top, right? Three 12 by 4 areas. And then we have two 4 by 4 areas. So let's multiply 2 by 4 by 4. And this will give me what? What's my total surface area? So my final answer here will be 264 centimeters squared. Cool, that's why let's call it, right? So volume, all right, and it's on top here, volume of any prism. What will be equal to?
The volume of the cross section.
The area.
The area of the cross section times the distance between the two cross sections.
Of the cross section multiplied by the distance. The distance between the cross sections. The reason why I don't use length or height here is because sometimes students go mad and they end up using the length as some other part of the cuboid or whatever shape you are given and end up getting it wrong. So establish what the area of your cross section is and then proceed to find the distance between the two cross sections if it is not given, right? So this here will be the volume of any prism. I'm saying it again. The cube and the semicircle will be the cross section. I actually have it shaded on that side already. That is your cross section. So can we find the area of the cube, find the area of the semicircle, add them together, you will get the area of the cross section, right? Then what will be the distance between the two cross sections, being this semicircle and square here and the other semicircle and square on the next side? What's the distance between the two? 12 centimeters is the distance between the two cross sections. This cross section on the side, that cross section on the next side, 12 centimeters is the distance between the two, right? So we're scrolling down. So we're going, let's find the area of the cross section. I put everything right here, area of cross section would be equal to the area of the square was 4 multiplied by 4. Everybody agrees? Plus area of the semicircle will be theta over 360, which will be 180 over 360 multiplied by pi r squared. Pi is 22 over 7 multiplied by what is the radius of that semicircle above again? Who remember it? What's the radius of the semicircle? 2, not 4, 2. All right? So this will be 2 squared, right? Radius squared. So somebody belt out as 1 on your calculator. So this is 22.3 centimeters squared, right? That is only the area of the cross section. So therefore my volume would be equal to the area of the cross section multiplied by the distance between the two cross sections, which we clearly said was 12 centimeters. What would be the volume of my solid above? Hit me. 0.6. Right, 0.6. And this will be centimeters what? Cube. So the solid is made from gold, right? 1 cubic centimeter of gold has a mass of 19.3 grams, right? 1 cubic centimeter. How much cubic centimeters did we calculate our volume to be? 267.6. But 1 cubic centimeter is 19.3 grams. They said the cost of 1 gram of gold is 42.62. All right? Calculate the cost of the gold used to make this solid. So here I go and find out. Could I find out how much grams this solid weighs? All right? So the let's put the mass. Mass of solid, right? How much is the mass of 1 cubic centimeter again? 19.3. How much cubic centimeters we have? 267.6. So can you tell me in grams what was the mass of my solid here? How much again? We got 5,164.68 grams, right? And then they proceeded to say that the cost of 1 gram is 42.62. So the cost of the gold will be what? What are we doing here again? Multiplying again. 68. That's how much grams we have. And the cost of 1 gram is 42.62. What is the cost of the gold here, my children? So this will be $220,118.66. So we on to January 2022, right? They are saying that at a track meet, a cylindrical container fitted with a pipe, as shown in the diagram below, right, is used to serve water to athletes, right? So you have a cylindrical container, and it's like them cone cups is what they pouring out water in, right? The cylindrical container has a radius of 12. Thank you. This is your radius here, and a height. This is your height here. Is completely filled with water, and the pipe fitted at the bottom dispenses water into the cone-shaped cups. The cone-shaped cups have a radius of 3, so they give you another radius here, and a height of 8. Okay? Calculate the volume of water in the cylindrical container in liters. Write your answer correct to 2 decimal places. Let's go. So the volume of a cylinder is pi multiplied by radius squared multiplied by height, right? We know what our radius is. We're dealing with the cylinder. We know what our radius is. Look at above here. That is 12 centimeters. We know what our height is. It's just a plug-in, right? So your volume would be equal to 22/7 multiplied by 12 squared multiplied by a height, which was what? 20. So what is my volume here? 9,051.43 centimeters cubed. But they did not want their answer in cubic centimeters. They want their answer in liters. So if you are going from cubic centimeters back to liters, you have to divide, right? So therefore, my volume would be equal to 9051.43 divided by 1,000, which will give me my volume as 9.05 liters. So water flows from the cylindrical container along the pipe into cone-shaped cups at a rate of 7.8 milliliters per second. 7.8 milliliters per second is the same as 7.8 centimeters cubed per second, right? Calculate the time taken to fill one of the empty cone-shaped cups. Give your answer correct to the nearest second, right? So this is very important, meaning that you have to basically approximate the nearest whole number, right? So there we go. We need to find the volume of the cone, right? Volume of the cone is equal to 1/3 by pi, which is what? And they said pi is 22/7. Even if they did not give it as 22/7, that's what we use once it's not given, right? And my radius would be 3 squared, okay, multiplied by my height, which is 8. What is the volume of one cone? 75 0.43, and this is centimeters cubed, right? Let's work this, and then when we write in the answer, we'll do it to the nearest second, right? So therefore, the seconds to fill cone-shaped cup would be equal to, it's going to be 75.43 divided by 7.8. I basically want to see how many groups of 7.8 I can get from 75.43. How much y'all get in here? Give me the original answer first. What you get? You get 9.1 or 8.1? 9.1? If we get 9.6, right? This is 9.6 seconds. Right? Seconds. So if they wanted to the nearest second, it will be approximately equal to 10 seconds. So it's approximately 10 seconds it takes to fill one cone-shaped cup, right? So I should put 1 here. So here was supposed to be 9.7, but you're getting the same answer, same 10 seconds, right? Everybody good there? Determine the number of empty cone-shaped cups in B that can be completely filled, completely being the operative word here, from the cylindrical container. So your cylindrical, so number of cups, right? Number of cups, right? Always think groups, right? So it's like, how many groups of 75.43 I could get from how much the cylinder was? 9,051 point something. 9,051 point something. What is? 43? Same 43? Yep. 43, right? How many groups of 75.43 I could get from that would be how much cups I could fill, right? 119, right? But it's 999, so to be approximately, right? 120 because they're real close, right? Cups. Okay? It's 120 cups. Right? Yeah. Farmer Brown makes troughs to feed his animals, right? His farm animals using wood that is 5 centimeters thick. You all see the shaded part there? That's the thickness, right? As shown in the diagram below, the troughs are rectangular base. Okay, thank you, rectangular base, right? Open at the top. So that means there is no trough, there's no cover at the top here, right? Underneath, on the inside, we would have a 5 centimeter thickness, right? But not at the top, okay? And have external dimensions. These are the external dimensions, right? Show by calculations that the internal capacity, which is the volume of the trough, is 8,091,000 centimeters cubed. Let me hear your ideas here, please. That's basically the cell out there. You're subtracting the thickness, right? Let me work with the internal length here. The external length is 300. What will be the internal length? The internal, right? So we're dealing with the internal length. What will be 300 minus what? What is the thickness on one side? 5. And what is the thickness on the next side? So what will be the internal length? That will be 290 centimeters. Let's deal with the internal width. Right? 190. 190 minus what? What is the thickness in front here? What is the thickness in front here? 5, same 5. What is the thickness in the back here? Same 5. Right? Because remember on the inside, you had a minus the 5 on this side, and you had a minus the 5 on this side for the inner width, right? And where again is to be? 180 centimeters. And what will be the internal height? This is the only one that would be different, right? What is the internal height? 160 minus what? 5 alone. Because it's just the base have a thickness, right? And this will give me 155 centimeters. So therefore, my internal volume would be equal to the internal length by the internal width by the internal height, right? Which would be 290 multiplied by 180 multiplied by 150, which gives me what? So once you work it out, you'll get 8,091,000 centimeters cubed. A little box to indicate that it was shown. It's supposed to be 155, right? 155. So to calculate the volume of the wood needed, you have the internal volume already. Find the external volume minus the two volumes. That will be the thickness of the wood, right? So let me go. So we're going to find the external volume, right? This will be equal to the 300 multiplied by the 190 multiplied by the 160, which will give me what? So that gives us 9,120,000 centimeters cubed. So therefore, the volume of the wood would be equal to 9,120,000 minus what was the inner volume?
8091000.
And what will be the volume of the thickness, aka the wood used, right? What that would be? 102. 110. Right. Yes, correct. And this would be centimeters cubed. So Farmer Brown must paint the internal surface. Look at big and bad here, the internal surface of the chuff, right? Given that 1 gallon of paint covers this amount, right? That's what 1 gallon of paint covers. 280,000 centimeters squared of surface. Determine the total amount of paint in liters that is needed to paint the internal surface of the chuff. The first thing I have to find is the internal surface area. Internal surface area. So there we go. I put down all my workings here as one. Give me one surface on the inside here. Remember on the inside here, so remember you had a minus 5 centimeters, right? What's one internal surface here? Huh? I put in the internal measures, right? What's the internal length? 290, right? What's the internal height? 155. What's the internal width?
180.
Right. Give my internal surface. Come on. So the area of this internal surface here would be 290 multiplied by 155 because this length from here to here would be 155, right? Now there are two of that because there's another one on this side. There's another surface on this side. So I could put 2 multiplied by 290 by 155. We have two more of our next internal surface. What is it? 180. So you have 180 multiplied by 155 surfaces, right? So that would be the surface on this side. So it's going to look something like this on the inside. That's how the... Somebody mic on. That's how the inner surface will look there. Something like that, right? I'm going to put the side in red. So it come down here, boom. Then it go up here. Bang. Then it come up here. Bang. Right? So that's how the internal surface looking, right? And that internal surface would be here. And that is 180 across 155 for the height. Right? And what is the last internal surface? Remember, it's 2. So we did here, we did here, we did here, we did here. One more surface on the inside we got to deal with. What that would be? So the base of this shape would be 290 multiplied by 180, right? 290 being the distance from here to here, that is 290. And then the other distance will be from here to here, which will be 180. That's the base. So when you work out this, what is the area of the, well, the total surface area of the inside of this box, right? 197,900 centimeters squared, right? And then they said 1 gallon of paint could cover this amount of surface. So therefore, gallons needed would be equal to the total surface, or the total internal surface, right? Divided by 280,000. How much is coming up to? So 0.7 gallons are needed. And they want their answer in liters. So how much is 1 gallon equal to? So if I want to go from gallons to liters, do I multiply or do I divide? Multiply. So this will be equal to, or you can put 0.7 gallons. Gallons would be equal to, let me write this a little better. So 0.7 gallons would be equal to 0.7 multiplied by 3.79, which will give me how much liters? 2.65 liters. Did they say to the nearest liter? No, they did not say to the nearest liter, right? So this answer will be 2.65 liters are needed. Right? In the question, take pi to be 22/7, right? Thank you, right? Right. So the diagram below shows a regular tank with base 50 centimeters by 40 centimeters, right? So that's like your length and your width. Then they proceeded to say that that is used to store water, right? The tank is filled with water to a depth of 15 centimeters. So the water didn't go straight up. It stopped right here at 15 centimeters. Calculate the volume of water in the tank. So everybody know the universal code for volume? Volume is equal to what? Who wants to tell me? What is volume? So you can't say area of the cross-section multiplied by the length of the cross-section. But this is a normal cube, right? So we could just use the straight formula for a cube, which is length by width by height, which is the area of the cross section. This is the cross section here, which is 40 by 15 multiplied by the distance between the two cross sections, which will be 50. It's the same thing, right? And that's using the standard formula here. So this will be 40 by 50 by 15. And what did we get for the volume of water in my tank? So 30,000, and this will be centimeters what? Cube. Proper. So we are on to part B. The cylindrical container shown in the diagram below is used to fetch more water, right? So we already know the volume of water we have above. So we want to fetch more water to fill the rectangular tank, right? The container, which is completely filled with water, has a radius of 20 centimeters and a height of 21. So it is easy to find the volume of this cylinder, right? So let me see what they're asking. All the water in this container is added to the water in the rectangular tank above. Calculate the total volume of water that is now in the rectangular tank. This correct, boy? Is 3 marks at this? Them serious? Volume of a cylinder. What is the formula for volume of a cylinder? Anybody?
Pi r squared by height.
Pi r squared by height. Proper thing, right? So they said pi is going to be 22/7. So this will be equal to 22/7 multiplied by radius, which is 20 squared, multiplied by my height, which is 21. What is the volume of water that can be filled into the cylinder, my children?
Cubic centimeters.
26,300, you all said, eh? 89 centimeters cube, right? Now, if I want the total volume of water that is now in the rectangular tank, I can't believe what's 3 marks of this. Total, what are we doing now?
The volume from the rectangular tank to the volume. I was calculating of the.
This is the easiest number 6 question I've ever seen. Right? This will be what? 5, 6389 centimeters cubed. 3 marks in the bag. So why all you not opening all your mouth? Remember, I don't have a calculator.
Pi r squared by height. Yeah.
Pi r squared, right, is radius squared multiplied by the height, which is 21, right? Okay? So they are saying it is not 26,389, right? So check over the ones who got 26,389, check it over. They are saying it's 26,400, right? So that means here I have to change to, and here. Somebody come on, I need some answers. This correct?
Yes, sir, that's the answer.
400, right? We good there? I don't have a calculator in front of me, guys. So next, they want you to show that the new depth of water in the rectangular tank is 28.2 centimeters. Let me hear your idea. They want us to show that the new depth of the water, which is like the height of the tank, right? They want you to show that the new height of the tank is 28.2 centimeters. That's what they want us to show, right? How do we show this? We know that the water went up and we have a new volume, which is down here, right? So this new volume would be equal to the length by the width by the height, right? This here will be the new height, okay? You have to work back. What is the new volume? Anybody, what is the new volume? After you pour the cylindrical container of water into the rectangular container of water, your new volume was 56,400, right? It's right here. Look at it right there, 56,400, right? Let me just write a 6 a little better. Okay? 56,400. This will be equal to the length. What is the length of the container up here? What do we consider as the length? The length will be what? So the length is 40, right? And the width would be 50, okay? So I'm going to put my length as 40, my width as 50, and this height here will be the new height that we're looking for. So could we work this out? Could we work this out? Get the answer, carry it on the side, and what do we do with it when we carry it there?
So divide it.
Right. What you getting when you work out these two here?
Divided by 2,000.
And this will be equal to my height. So therefore my height will be what?
2.2 centimeters.
2.8.
2.8? Nah.
I got 28.2.
28.2 centimeters, which is what they asked us to show. Shown. So, the vertical height of the rectangular tank is 48 centimeters, right? That is the actual height. So I'm going up here. So the complete height of the cylinder, which is top to bottom, is 48 centimeters, right? Okay? Now, determine how many more cylindrical containers of water must be poured into the tank for it to be completely filled, right? It has two ways to do this, right? Number one is we know this height here. We know the height it is at right now is 28.2. So I can calculate how much more of the height needs to be filled, right? So I can put the height remaining, if you want to call it that, right? Remaining to be filled. That will be equal to the 48 minus the 28.2. How much this area is? I mean, how much this height is here? How much more centimeters we need to fill in order to get the tank filled? So this will be equal to 19.8 centimeters, right? That's how much more centimeters we need to go in order to fill the tank, right? So I can find the volume of water needed to fill the tank, right? So volume of water needed, right? And this will be equal to the length, which was 40, by the width, which was 50, by the height needed, which is 19.8. What volume of water do I need in order to fill this tank here? 39,600 centimeters cube is needed to fill the the cuboid shaped container. But it asks me how much more cylindrical containers I need to pour into the rectangle, the cuboid to fill it, right? So I could put here cylindrical containers needed. I could use the same word needed, right? What would my work in here be to find out how much cylindrical containers I need to get that 39,600? It's going to be 39,600, which is the volume of water needed, divided by the volume of one cylinder. If I divide this into 39,000, I'll be able to find out how much containers are needed. So what this works out to be? 1 point what?
1.5.
1.5 containers exactly. Okay? So we are on to January 2020, number 6, right? The radius of each circle in the rectangle WXYZ shown below is 7 centimeters. That's the radius here. The circles fit exactly into the rectangle, right? Show that the area of the rectangle is 2,352. If they fit exactly, that means if I put an X radius here, right? That radius joins to this radius exactly, right? There's no space in between. That's basically what they mean when they say what they said, right? So that's all. Let me see if I could get this to join. Woo. Right. Boom. This joining with this one here, right? Exactly, yeah? So with that being said now, let me hear your ideas with what would be the length of the rectangle here.
Alright, so if the radius is about centimeters, I just find the diameter, which is 7 plus 7 is 14. And for the length, I take, if it's 4 going across, it would be 4 multiplied by 14, which is 56.
Proper.
And the height going down is 3 going down, so it would be 3 multiplied by 40, which is 42.
So you could have done 4, excellent, Josiah. You could have done 4 multiplied by 14, or what I would have done, I would have done,
do 8 by 7.
yeah, I would have done 8 by 7. I would have done 8 multiplied by 7 because it's 8 radii going across. This is 1, 2, 3, 4, 5, 6, 7, 8, right? And 8 sevens are
56.
and then we have our breadth. How much radii we have coming down here?
6.
6. So this will be 6 multiplied by, right? So 42 centimeters. Therefore, my area of the rectangle would be equal to length multiplied by breadth, which would be 56 multiplied by 42. And this is supposed to give you 2,352 centimeters squared. Are we looking there? So they want us for part 2 to calculate the area of the shaded region, right? I calculate the area of one circle multiplied by how many circles I have. When I get that area, I'm going to minus it from the area of the rectangle, which is this area here. So let's proceed to find the area of one circle, right? So area, or I could put area of circles one time, you know. Circles. How many circles do we have?
You could find 12.
12. So I just doing 12 multiplied by pi r squared. Everybody agrees because pi r squared will be the area of one circle. So this will be 12 multiplied by 22 over 7 multiplied by 7 squared, which is my radius squared. What is the area of all these circles?
1848.
1848 centimeters squared. Come on, let me start to cook now, man. So therefore, the area of shaded region would be equal to 2,300 and what?
52.
minus 1848, and that'll give me how much centimeters squared?
504.
Cooking. We are cooking. Right, let's go. Right, so let me go. The diagram below, not drawn to scale, shows triangle MNP in which angle MPN is equal to angle PMN at 50, well, which is 52 degrees, right? And they said that MN is equal to 12.5. Now, if he has 12.5, he has 52, and he has 52. What will be this angle over this line over here, which is PN? This line will be how much? 12.5, because this is a what type of triangle? Isosceles. Oh, look, that's the first part of the question, yes? So, state the type of triangle shown above isosceles triangle. Determine the value of P and M, right? P and M would be up here. The three angles in a triangle add up to?
180.
So, P and M would be equal to 180 minus 52 plus 52, which will give me what?
26.
76 degrees. Then we need to calculate the area of the triangle MNP, right? So if we want the area of the triangle MNP, there's a formula, right? Now we're not going to use base by height over 2. There's a formula. Here's 76, right? Degrees. There's a formula, and I want you to write it. It comes in your formula sheet. Saying it again, right? Area of triangle ABC would be half AB sine C. A and B being the two sides forming the angle capital C, right? Down in the question underneath, common A would be 12.5. This side would be 12.5 also, and capital C would be 76. So let's plug that into this formula, and you'll get the area of your triangle, right? So that is the formula we're going to use down here, right? So there we go. So area of triangle would be equal to half AB sine capital C, right? As I said, common A is this side, common B is this side, capital C would be here. Okay, let's plug them in. This will be a half by 12.5 by 12.5 sine of capital C, which will be 76. When we work out this, what do we get? 75.8 centimeters squared. So we are on to June, did I say June 2019? Yes, June 2019, right? So they said the scale on a map is 1 to 25,000, right? So if I say 1 to 25,000, I talk about 1 centimeter to 25,000 centimeters in real life. That's how that scale works, right? So if I draw 1 centimeter line here, in real life on a map, right, it'll be 1 centimeter, but in real life, it'll be 25,000 centimeters. That's how scale works, right? So the actual distance in kilometers represented by 0.5 centimeters on a map. The first thing I want to put straight off the back here is that 1 kilometer is equal to how much centimeters? Let me hear you all. 1 kilometer,
100,000.
100,000, proper. Stick that in your brain somewhere. 1 kilometer is equal to 100,000 centimeters, right? So if I want to show 0.5 centimeters on the map, look at something. 1 centimeter is basically 25,000 centimeters, right? So 0.5 centimeters would be equal to 25,000, right? Multiplied by 0.5. Okay, so it's like half of this. And what you'll get there? Half of that is what?
Wait, let me get that.
Did you?
I just divided by 2.
Yeah, you can divide by 2, you'll get the same thing, right? So if I want, it's 0.5 centimeters, just as like half of this, right? 0.5 is 1/2, okay? So 0.5 centimeters is equal to 12,500 centimeters on the map. But I want to change these centimeters now to kilometers. So what do I do? Multiply or divide by 100,000? Divide, proper. So therefore, 12,500 centimeters would be equal to 12,500 divided by, I don't like to put a division sign on it, divided by 100,000, and what it gets in here?
0.125 kilometers.
Somebody second this, please.
The second.
So for the next part of the question now, right? This is where you could get tied up very, very easy. So lock in, right? Calculate the area of 1 kilometer squared represented by 2.25 kilometers squared, right? I want to draw a 1 by 1 box here. So this is 1 centimeter by 1 centimeter. The area of this box would be equal to 1 centimeter squared, right? But if I can know how much kilometers this is here, I could actually find how much 1 kilometer squared will be, right? So 1 kilometer, not 1 kilometer, sorry, 1 centimeter would be equal to how much kilometers, right? Now this here, this up here, this is 0.5 or half of a centimeter, right? So if I want 1 full centimeter, it will be 0.125 divided by 0.5. How much is 1 centimeter represented by in kilometers? Somebody give me the answer there. 0.25 kilometers is what 1 centimeter would be on the graph or the map, right? So instead of putting 1 cm by 1 cm here, I'm going to draw back the same square, right? Okay, copy, paste, right? So instead of doing 1 by 1, right, I'm going to write now 0.25 kilometers by 0.25 kilometers, right? So how much would the area of this square be? 0.25 multiplied by 0.25 is what? What is the area of the square? How much kilometers squared would this be?
0.0625.
0.0625 kilometers squared would be the area of the same box. So you know what I could derive now, or I could come up with? I could say therefore 1 centimeter squared is the same as 0.0625 kilometers squared, right? But they want us to show 2.25 centimeters squared on the graph, right? The actual distance for that in kilometers squared. So I can put this implies that 2.25 centimeters squared would be equal to, am I multiplying by this or am I dividing? It's like you want to go from centimeters squared to kilometers squared. You have to multiply. So this will be 2.25 multiplied by 0.0625. How much kilometers squared will this be? So your answer here will be 0.140625. If you leave this as centimeters squared, you'll get the answer wrong, right? You would get the answer wrong. This is your final answer here. So the diagram below, not drawn to scale, shows the cross section of two cylindrical jars, jar X and jar Y. The diameter of jar X and jar Y are 3D and D centimeters respectively. Initially, jar Y is empty, and jar X contains water to the height, which is the depth of 4 centimeters. This is all the information that they gave us. Now they said determine in terms of pi and D the volume of jar X, the volume of water in jar X. What's the volume of a cylinder? Anybody? What's the volume of a cylinder? I didn't realize this was so easy. What's the volume of a cylinder? Pi r squared by height. Dog to the dogs of food, right? So they say leave pi, leave d, eh? So this will be pi by what is my radius here? This radius would actually be, we're looking at jar X, eh? The radius would be 3d divided by 2 to the second power. Let me know if you all agree with me. 3d divided by 2, because 3d is the diameter. So you must divide it by 2, right? And then we're going to multiply it by height. What is my height? What is the height of water here? 4, right? So let me do some breaking down now. See what can happen. This 2 could go into this. No, wait. Let me square this first, right? Okay? Leave this 2, leave this 4. Square everything inside here. So this will be pi, and in the brackets, I would have 3 squared and d squared. 3 squared is 9. D squared will just remain d squared. All over 2 squared is 4 by 4 over 1. Now, this 4 can cancel with this 4 here, right? And we would remain with pi, 9, and d squared. I'm going to put the 9 first, so it will be my coefficient. Then you can put pi first or d squared first, whichever one. This will be broken down to be the volume of water would be 9 pi d squared. Raise your hand if you got this right. Now, when I love that you're asking questions, eh? When I have r is equal to 3d over 2, that's why I got the 3d over 2 here for r. If I need to square this, right? If I want r squared and I need to square this squared applies to every single term within the brackets. So r squared would be 3 3s are 9, d squared remains d squared, and 2 2s are 4. That's why I get the 9d squared over 4. Are we clear? Let's change the subject of this formula according to Andrew, right? So let me go. If all the water in jar X is poured into jar Y, calculate the height of it, right? So we know that the volume, this is jar X. Jar X. This is poured into here. So we want to know when you pour that volume into here, what the height would be, right? So we don't know the height for this one, okay? So basically what is going to happen is I can say the volume of water that we poured in is equal to pi r squared by height, right? Volume of water in jar Y is equal to pi r squared by height, right? But we know the volume is 9 pi by diameter squared. And this will be equal to pi r squared by height, right? That's so we know what is the radius for this jar now. What will be the radius of this jar? Who can tell me? If the diameter is d
over 2
proper,
squared.
your radius will be d over 2, right? So we're going back down here. So this will be, I put back the 9 pi d squared because that's the volume of water in jar Y now, right? And this will be equal to pi, and then I'll have d over 2 squared, and we don't know what height is. We do not know what height is, right? So leave that as h. That's what we're trying to find. You're trying to find the height that the water would reach, right? So d squared over 4 is what this will be, right? So 9 pi d squared is equal to pi d squared over 4, right, by h. So what's something here, right? I can take this 4 because this pi d squared h, you can actually read this as all of that over 4. That is what that can read as. So I can take this 4, carry it to the next side, and do what? What do I do with this 4 when I carry it here?
Multiply.
So this will be 9 multiplied by 4 pi d squared is equal to, could I just rearrange this and put, not rearrange, let me leave it as pi d squared by height. I was going to put the h in front. Right, so wait, we come in there. So what's something now? You all realize we have pi d squared on this side and pi d squared on this side. So it's like you could cancel it out, but I don't really use the canceling out method, so let me use what I use. And this, you can take this pi d squared, carry it here, and do the opposite of multiply, which is to what?
Divide.
So this will be 32 pi d squared divided by pi d squared is equal to h. This cancels with this h, therefore h is equal to 32. 9 multiplied by 4 was 36, not 32. I don't know where I get 32 from, right? Is the bush cause that?
Okay.
So we are on to 2019 January, right? So they said the diagram not drawn to scale shows an open cylindrical container made of metal with a cylindrical base and uniform thickness throughout, right? Now, uniform thickness throughout means that the thickness down here, right? The thickness down here would be the thickness at the side here, right? Same thickness above here, uniform thickness throughout. Now they said the length of the container from the top to the bottom is 120 centimeters. The inner thickness, well, the inner and outer radii are 14 and 15 centimeters respectively. Draw a cross-sectional view of the container showing the measurements of the inner and outer radii, right? So yeah, that's drawing two circles, you know. That's what y'all did? Y'all,
Yes, sir.
two circles, right? The inner radii will be how much? How much the inner radii is?
14.
14, right? So here, I ain't get perfect, but here's 14, boom. Here's 14 centimeters, and what the outer radii will be?
15.
15 centimeters, right? So this is 2 marks in the bag there one time. So show that the capacity of the container is 73,304. Now the capacity of the table of the container is simply the volume of the inner cylinder. But volume of a cylinder is what again?
Pi r squared by height.
Pi r squared by height. Now we know pi is 22/7. We know the radius of the inner part because this outer part is a thickness. That is not where no liquid could pour into there. The liquid part we're looking at would be this part only, okay? This part only we are looking at. So the inner radii was what? 14.
14.
Right? So this volume would be equal to 22/7 multiplied by 14 squared multiplied by height. But what is my height of my inner cylinder?
119.
Right. Why?
Get all from one.
Why? Because this thickness here is actually 15 minus 14, which is 1 centimeter. That is the thickness. But they said uniform thickness throughout, right? So down here would be 1 centimeter also, right? So if you want the inner height, it would be 120 minus 1 centimeter, which would be 119. Well, 120 minus 1, which is 119 centimeters. Cool? So that's what we're working with down here. And when you work out this, you're supposed to get your volume is equal to 73304 centimeters cubed. Shown. Alright? Everybody good there? Call it shut. We already found the volume of the inner capacity or the inner cylinder, right? So determine the volume of the material used to make the container. We need to find the outer. Outer is 2 T's or 1? 1 T. This will be outer. The outer cylinder would be equal to same pi, well, volume, right? So this will be same pi by radius squared by height. Pi will be 22/7 multiplied by, what is the radius of the outer cylinder?
50.
15 squared multiplied by what will be the height of the outer cylinder?
120.
Proper. And when we work out this here, what will be the volume of the outer cylinder?
84,857.14.
8,400 and what?
57.1.
57.1. 14?
Yeah, 14.
Yeah, 1/4.
Centimeters cube, right? So therefore, the material or volume of material used, like a volume, therefore volume of material used would be equal to 84857.14 minus what was the inner volume? 73 something, 73,304. How are we getting here?
11,553.14.
Somebody second this.
Yes.
So given that the density of the material used to make the container is 2.2 grams, 2.2 grams per centimeter cube, determine the mass in kilograms of the empty container, right? We want the mass in kilograms of the empty container. So,
What directed my face?
hey, your mic on by Isaiah. So let me go.
The answer was directly in my face.
Yeah, it was directly in your face. So density is equal to mass over volume. So if I want the mass, it was that?
I mean, like 2.2 multiplied by
By the volume?
11, yeah, literally.
So you gotta carry the volume on the side, so it'll be volume multiplied by density is equal to mass. Once again, changing the subject of your formula is everything, right? So volume was what? What was the volume of the material used we working with there? What's the volume of the material used?
1153. No, 11. 553.14.
553.14. 11,553.14 multiplied by 2.2. What is my mass here? And this mass will be in grams. Go ahead.
24,416.91.
Right, so therefore mass is equal to 20 what?
25,000.
25,000.
416.91.
And this will be in grams, but they said they want their answer in kilograms. So 1 kg is equal to how much grams?
1,000.
So I'm trying to go from grams to kg. Do I multiply or do I divide?
Divide.
So this will be equal to 25416.9 divided, well, 91 divided by 1,000, which will give me what to 2 decimal places?
25.4 kg.
25.4, like 0.42 kilograms. Did they say to the nearest kilogram? No, right? And this is my final answer here. So we are on to June 2018, right? Number 6. In this question, take pi to be 22/7. The diagram not drawn to scale shows the cross-section of a circular metal disc of radius 21 millimeters, not centimeters. A square hole with width 6 millimeters is located at the center of the disc. What is the circumference of the disc? That's food. Circumference of a circle is equal to what? 2 pi r. So this will be equal to 2 multiplied by 22/7 multiplied by 21. What's the circumference? Quick.
132.
132 millimeters, right? That's the distance around. Now they said the area in millimeters of the cross section of the disc, right? So the area in millimeters of the disc, right? Now this is a square hole, so we will have to minus this. Let's find the area of the full disc. Find the area of the square because it's a square hole, right? Meaning there's nothing there. And minus it. So let's go with area of circle first. What's the area of a circle?
Zoom out, just zoom out just one little bit. Then you
Sure.
get a chance.
Pi r squared, right? So this will be 22/7 multiplied by 21 squared, which will give me what? What's the area of the circle? This is June 2018, right? So this answer will be 1,386 millimeters squared. Somebody needs to second this answer, please. And I need to find the area of the square hole. Right, that's correct? 6 6s up, 36 millimeters squared. So therefore, the area of the cross section would be equal to 1386 minus 36, which will give me what?
1350.
1350 millimeters squared, right? Everybody good here? 1350 millimeters. So the next part, they said, given that the thickness of the disc is 2 millimeters, calculate the maximum number of discs that can be constructed from 100 centimeters cube of available metal, right? So the first thing I need to do is find the volume of one disc, right? That will be equal to the area of the cross section, which we already found, right? Multiplied by the distance between the two cross sections, right? So area of the cross section was what? It was 1,350 multiplied by the distance between the two cross sections will be the thickness of the disc. That will be 2. And what we'll get here, what this works out to be?
2700.
Millimeters squared, right? But we need to convert this to centimeters squared.
Category millimeters cubed.
Right, it's volume millimeters cube. But we need to convert this to centimeters cube, right? So if you're going from millimeters cube back to centimeters cube, what do? Divide or multiply?
Divide.
So this will simply be equal to 27. This will be equal to 2,700 divided by 1,000, which will give me 2.7 not millimeters, centimeters cube. All right? That's the volume of one disc in centimeters cube. So how much could we get from 1,000 centimeters cube? All right? So number of disc would be equal to 1,000 what? Multiply or divide by 2.7.
Divided.
And this will give me how much?
370.
370 flat?
70.
370. 370.
370.3.
Right, 370.3, but what after the 3? Right, so it's 370.4, right, which is approximately equal to how much? 370 disc, right? Because they want the maximum number of disc you could make. The maximum number of disc you could make is 370 disc, right? Everybody good there? So a globe is a scaled spherical representation of the Earth. The actual length of the equator is 40,000 kilometers, right? Now, with respect to spherical spheres and latitude and longitude and those things off the syllabus, right? But this is still like a scale drawing. That's why I still want to do it, right? So 400,000 kilometers is represented on the globe by a piece of string 160 centimeters, right? So can I say that 160 centimeters is equal to 40,000 kilometers in real life? Can I say this, guys? Yes or no? So 1 centimeter would be equal to 40,000 divided by 160, which would be how much?
250.
250 kilometers, right? So therefore, 500 kilometers in real life is the actual distance. How long would the string be on the globe? That would be 500 divided by 250, which will give me how much? 2 centimeters on the globe. Right? Scale drawing. They said the distance between Palmyra and Quintec is represented on the globe by a string 25 centimeters. Calculate the value of PQ, the actual distance in kilometers. 25 centimeters, guys. How much is 1 centimeter?
By 250.
That what I tell you, it's like it's too easy to be true. 25 centimeters would just be 25 multiplied by 250 because 250 represents 1 centimeter. And it's to be equal to how much?
6250.
6250.
Kilometers is the actual distance. I couldn't believe how easy that was, right? So guys, we come to the end of our number 6s. Boom, bang. You know